In 1986, the Chernobyl power plant near the town of Pripyat in modern-day Ukraine blew up in a reactor core meltdown because of a poorly thought-out experiment in which the workers turned off the safety measures while allowing the reactor to continue running, leading to a core meltdown and numerous deaths due to the explosion and radiation poisoning from the radiation put in the atmosphere. The horrificness of this disaster was a turning point in attitudes toward the use of nuclear power that led to changes in the use of safety measures. History of nuclear energy. Before we can understand how Chernobyl impacted history, we need to know how history impacted Chernobyl. The history of nuclear energy started way back in 1789 when uranium was discovered. It was named after Uranus. Nuclear reactions are caused by the splitting of atoms, and uranium is one of the easiest atoms to split, making nuclear development easier, which means that the discovery of uranium was very important in nuclear development. Ionizing radiation was discovered over 100 years later, and as the study of radiation and the ways of bringing about nuclear reactions improved through the works of people like Einstein, people eventually figured out that a self-sustaining, fuel-producing reactor using nuclear energy was possible. The idea of harnessing nuclear fission like this eventually led to destructive things like the atom bomb, along with beneficial things such as the creation of the first nuclear reactor to produce electricity, EBR-1, a reactor built in Idaho that powered 4 200-watt light bulbs. It was a liquid metal-cooled fast reactor. This reactor, which was activated on December 20th, 1951, pioneered the field of nuclear reactor development. At some point during an experiment, there was a partial core meltdown, but it resulted in a better understanding of the thermal capacity of the materials used for testing. This contributed to advancement in the field of nuclear energy. In 1954, the Obninsk APS-1 in Russia sent 5 megawatts of power to the grid. And back in Idaho, another reactor was able to power a small nearby town called Arco. Eventually, the U.S. made the first fully commercial reactor in 1960, and countries around the globe started up their own commercial reactors within years. In the midst of all this, however, more was brewing underneath the surface. Soon after the Second World War truly showed the destructive power of nuclear energy, the U.S. and USSR engaged in a Cold War in a battle of communism versus capitalism, which resulted in a nuclear arms race and even more investment into the field of nuclear energy. This war was named as such because it never ignited into a full-on war. The study of nuclear energy in the USSR, however, began back in the first half of the 1900s. Creation of Chernobyl. After nuclear reactors went commercial, the Soviets had their first 2 commissioned in 1964. Soon enough, in 1983, the Chernobyl plant was fully completed. Unfortunately, it was created in a way where a lot of damage to a few fuel assemblies would cause a lot of problems. They wanted to keep up with the progress of the U.S., leading to the use of cheap materials, and also leading to them making their reactor quickly and without enough caution. In fact, a memorandum had been created that made clear the fact that there were some structural flaws that could and would lead to mishaps and catastrophe. This is where things began to turn for the worse.
On April 25, 1986, the day before the disaster, the workers began to prepare for an experiment that became the cause of the Chernobyl disaster. The experiment was to test the reactor's turbine ability to continue spinning long enough during a power outage, and the lack of cooling pipes to sustain the cooling feed water pipes. The experiment originally called for a slow and gradual slowing of power. Instead, the reactors brought down the power rapidly, causing the chain reaction happening in the reactor to become harder to control, causing the reactor to slower power. To bring in the reactor to normal power levels, the operators removed more control rods than they would in a normal condition, making the reactor to become unstable. Despite this, the experiment operators still allowed the experiment to continue, even under dangerous conditions, as to conduct the experiments. they had to disconnect every important safety system, including the emergency core cooling system and every backup electrical system, which would have allowed them to use the reactor controls in the event of an emergency. In spite of the lack of safety precautions, the engineers proceeded with their experiment by shutting down the turbine generator, which cut the electrical supply to the reactor's water pumps. This then caused a reduction in the amount of cooling water entering the reactor. Due to this lack of cooling, the water within the cooling pipes in the reactor's core began to boil and turn into steam, causing a power surge. The test operators noticed a sudden jump in power and figured out that they needed to drop the control rods to slow down the reaction. The operators started the scram procedure, in which a motor dropped all 205 control rods into the reactor. This decision turned the situation from bad to worse, as there was a fatal design flaw in the control rods: the fact that the tips were made of granite. This was an issue, as instead of absorbing neutrons like the water, granite reflects neutrons, so when all 205 rods dropped into the reactor without cooling water to absorb all the neutrons, they began bouncing off each other in the granite tips, making the reactivity skyrocket and the reactor exploded. The explosion was caused by a mix of hot fuel and cooling water, creating a lot of pressure. This pressure build-up caused issues within the core, which led to a core meltdown and explosion, causing a chain reaction to occur in the core due to the lack of control rods to stop the reaction. The fourth reactor of Chernobyl caused a giant fireball to emerge from it, killing one person during it but more after, while also setting fire to the building. The blast of the explosion was so big that it caused the heavy steel concrete lid to flip off the reactor, ripping the roof off the building.
Chernobyl's consequences. The reactor explosion spewed radioactive particles into the atmosphere around a 30-kilometer radius that became an exclusion/evacuation zone inside of Chernobyl. Those same radioactive particles also contaminated around 125,000 square kilometers of land in Belarus, Ukraine, and Russia. Contaminated soil used to grow crops would result in food that contains radionuclides that damage the body cells and cause different types of cancers. In order to limit further environmental damage, a steel and concrete sarcophagus was placed around Chernobyl. The official death toll was 31 people, which was caused by receiving high doses of radiation and suffering from radiation sickness. The person eventually found guilty and sentenced to jail for Chernobyl was Viktor Brakhanov. He was found guilty of violations of safety regulations as he was in charge of the power plant as chief administrator. As a result of Chernobyl, there was a global effort to improve nuclear safety globally, with questions about the safety of nuclear power plants and what to improve to prevent another disaster. Chernobyl's mark on the world. Years later, the National Research Center for Radiation Medicine estimated that 5 million people from the former USSR were affected by the radiation from the disaster. As a result of Chernobyl, several governments decided to phase out nuclear energy programs, and others decided against proceeding with new nuclear programs, creating a negative sentiment towards nuclear energy. However, some good still came from Chernobyl. To avoid a situation like Chernobyl, the USSR invested millions of dollars in upgraded safety of their reactors. They also tried to fix deficiencies in other reactors, and the prevalence of what happened turned the attention of many Western plants toward maintaining the safety of their plants. Chernobyl also influenced international agencies like the International Atomic Energy Agency to improve safety standards with the use of international legal instruments that are used to respond to criminal and other unauthorized acts involving nuclear material, with practices such as the Convention on Nuclear Safety. Some independent agencies, like the U.S. Nuclear Regulatory Commission, did a post-Chernobyl assessment to find the importance of many concepts like maintaining proper procedures, the availability of backup safety systems to deal with potential accidents, and having competent and motivated plant workers, staff, and management. Chernobyl also influenced a global strategy for occupational safety and health at work, being adopted by the International Labor Conference, with Chernobyl being particularly caused by a lack of safety culture. Today, living within the Chernobyl exclusion zone is considered illegal, though the authorities still tolerate people living in some of the less irradiated zones. In addition, guided tours were organized in 2018 from Kiev and to and from the exclusion zone. However, they have since ended. Today, Chernobyl serves as an example of the risks of poorly handling nuclear energy, and the world has since evolved past the disaster to ensure safety in the production of nuclear energy.